Welcome pre-cal students to the homework help video, page 872, numbers 1 through 41, every other odd, and then 51, 55, and 59. Go ahead and get out your homework, your books, your notes, pens, papers, calculators, and let's get started. Hopefully this homework help video will help you find the mistakes and the problems that you're not getting right. Here we go. Let's take a look at numbers 1 through 9. The directions say, find the common ratio. Now some of these you can kind of just do in your head by looking at them, and others you'll have to actually do some work. This one to me is very obvious. My common ratio is 2 because I'm taking 2 times 2, 4 times 2, 8 times 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So I'm multiplying every term by 2. That's pretty easy to see. Now number 5 is a little more difficult because you're dealing with fractions. So instead of experimenting and guessing, just pick any term you want. I'm going to pick this one and divide it by the term immediately to the left. So negative 4/3 divided by 2/3. Now of course we know by now when you're dividing fractions you flip the second fraction and you multiply, and your 3's would cancel and your 2 would cancel into your 4 2 times, and you get a negative fraction times a positive fraction is negative. 2 times 1 is 2. 1 times 1 is 1. So the common ratio is negative 2. And by the way, you can check that. If you take 2/3 times negative 2, you'll get negative 4/3. If you take negative 4/3 times negative 2, you'll get 8/3, and so on and so forth. Okay, number 9. Let's find the common ratio. Pick any term you want. I'm going to pick this term, it doesn't matter which one, and divide it by the term to the left of it. So 5a cubed over 8. Now look, it's divided by this, so I'm going to skip a step. I'm going to put times, and I'm going to go ahead and flip this fraction now. So 4 over 5a squared. Now your 4 would cancel into your 8 twice. Your 5 would cancel with the 5. You have 2 a's here. Let's take away 2 a's, take away 2 a's, and you're left with 1a. So a times 1 would be a, and there's nothing here, so we'll put a 1. 2 times 1 is 2. Now I know you're used to getting a number for your common ratio, but this is fine. They were just kind of checking your algebra ability there. But there we go. Your common ratio would be a over 2. Let me get a drink here and we'll continue on. Alright, numbers 13 through, let me push this button here. Okay, numbers 13 through, just number 13, it says find the indicated term. So we're going to find the 9th term. Now, students, it's okay to realize we have term number 1, term number 2, and term number 3, and find what the common ratio is and multiply it over and over until you get to the 9th term. I have no problem with that. But remember, on the test, I might ask you to find the 57th term. So the best thing to do when you're looking for a term is to find the nth term, and then once you know the nth term, you can put 9 into your nth term and get out the 9th term. So my recommendation for you is let's go ahead and find the nth term. Now, on a test or a quiz, you have to make sure you have a geometric sequence before you use this formula. This formula only works when you're looking for the nth term of a geometric sequence. Now, we do have a geometric sequence here. I'll tell you that right now. We're multiplying the square root of 3 over and over. 2 times the square root of 3 is 2 square root of 3. And if you took 2 square root of 3 times square root of 3, you would get, well, there's a 1 on the outside here. 2 times 1 is 2. Square root of 3 times square root of 3 is square root of 9. And the square root of 9 is just 3. And 2 times 3 is 6. So we are multiplying over and over each term by the square root of 3. So we do have a geometric sequence, so we can use this formula. So the nth term would be a subscript n equals, next is a subscript 1, that's the first term. Next right here would be r, so I'm going to put my common ratio, which is square root of 3, and then next is n minus 1. So I put n minus 1. And now let's find the nth term. So where this n is right here, I'm going to go ahead and put a 9. So I would have 2 square root of 3 to the 8th power. Alright? Now, if you type that into your calculator correctly, you're actually going to get out a whole number. And by the way, you would not multiply 2 times the square root of 3 first. With your calculator, you would simply type in the square root of 3 and be sure and close the parentheses, so it'll look like this: square root of 3, then hit your power button so the arrow comes up, and then hit 8. And you will get out 81, and then times 2. So 2 times 81 is 162. So there's the 9th term. Not too bad. Okay, let's take a look at numbers 17 and 21. The directions for 17 and 21 say, find the nth term or the general term. Let me get a quick drink here. And I do notice I accidentally left the answer on here. I'm not really worried about that. We're going to work it out anyways, but nonetheless, we'll just ignore that for now. Okay, let's find the nth term. This is a geometric sequence. You're multiplying each term by 3 over and over. So your first term would be 1. Your common ratio would be 3. And this is the formula that gives you the nth term for a geometric sequence. So a subscript n equals, notice next is this, that's my first term, which is 1. Then next comes r, which would be 3, and then I would put n minus 1. And there we go, you found the nth term or the general term. If you want to test it, you could put a 1 in and you would get out a 1. Put a 2 in for n and you would get out a 3. Put a 3 in for n and you would get out a 9. Okay? All right, number 21. Let's write the nth term. First of all, we have to find the common ratio, and the way we do that is we circle any term and we divide it by the term to the left of it. So 1 over x squared divided, I'm not going to put divided, I'm going to put multiply, and I'm going to go ahead and flip this fraction, so times x over 1. Now I have 1x here, 2 down here. I'm going to take 1x away from there, so I'll take 1x away from here. 1 times 1 is 1. X times 1 is x. So I found my common ratio. So it looks like, let me very quickly move this down, get some space. So it looks like my first term is 1 over x, and my common ratio is also 1 over x. So the nth term would be, here's your formula right here. Your nth term is a subscript n equals, and then next comes your first term. So I would put 1 over x, and then next comes r. So I would put 1 parentheses 1 over x for r, and then next is n minus 1. And that would be the nth term. All right. Now the answer in the back of the book on this one, in case you have a different answer, or in case you have this answer and the back of the book has a different answer, there is a way to simplify this, and I'm not going to get into it, but this is totally acceptable. What they probably did, I noticed the back of the book has a different answer. What they probably did is they said 1 right here is to the 1 power, and when you're multiplying 1 times 1, you're multiplying like basis, so you can add the exponents. So if you take 1 plus n minus 1, you just get n, and then x times x is x squared. So they simplified, and they probably came up with something like this, I'm assuming. Actually, this n minus 1 would go for the numerator and the denominator, but either way, we do not have to do all that. This answer is totally acceptable. Okay. All right, let's take a look at number 25. Find the sum of the first 9 terms, okay, of the geometric series. Now, please listen to me carefully. First of all, it does tell us in the problem we have a geometric series. If they did not tell us that, we would have to check and see on a test or a quiz. Now that we know that we're finding the sum of a geometric series, there's 2 formulas we have to choose from. One of the formulas we use, which is this one here, when we know how many terms we're adding up, and we know we're adding 9 terms. So this is the formula we're going to use. This formula here is used when we're finding the sum of an infinite geometric series and we don't know how many terms we're adding. Remember, this is a situation where r has to be greater than -1 and less than 1. We've talked about that. And so those are the two formulas you have to choose from when dealing with a geometric sequence. Okay, so we are going to use this formula right here that's circled, because we do know how many terms we're adding. And notice, to use this formula, we have to know what the first term is, and we have to know what r is. Now we know what the first term is. The first term is 1/18. We do not know what r is. So we pick any term and we divide it by the previous term. So I'm going to take 1/2, and I'm going to go ahead and flip the fraction. So times a -6/1. Well, first of all, a positive fraction times a negative fraction is negative, and then 1/2 times 6/1 is 3. So your common ratio, and if you're confused here, just use your calculator, your common ratio is -3. Alright, so I am now ready to find the sum of the first 9 terms, and here's the formula I'm going to use. So S subscript 9, that means I'm adding up 9 terms, equals, okay, my first term goes up top, so 1/18, then parentheses, 1 minus, and then parentheses, -3 to the 9th power. And see this n right here? I know that's a 9 because I'm finding the sum of 9 terms, and that's all over 1 minus a -3. Now, what I've told you to do in the past was this right here for the numerator. I would leave 1/18 where it is, and with your calculator, I'm going to go ahead and very quickly simplify the bottom here. You would have 4. 1 minus -3 is 4. But back to the numerator here at the top of the fraction, I would type this whole thing into your calculator very, very carefully. I would hit 1, then hit minus, and then hit a parentheses, and then -3, and then close your parentheses, and then the exponent button, which would be an arrow like this, and then 9. And that's going to be the best way to type in this whole parentheses. I would not try to do the whole numerator. I would just do this part first. I really would. And you're going to get this right here, 19,684. And now multiply that times 1/18. And what you're going to get for the top, for the numerator, is 9,842 all over 9. That's the top of your fraction right here. So that's all over 4. Okay? And then if you take this fraction right here, and by the way, when you type into your calculator, be sure and use parentheses. Okay, so when you type this top in, it would be parentheses, and then 9,842 divided by 9, close your parentheses, and then divided by 4, you will get 4,921 over 18, or if you like decimals, the decimal would be 273.38, repeating. Now, be able to give me both of these because I might ask you for a fraction or a decimal, so know how to use your calculator really well there. Okay, let me grab a quick drink here and we will continue on to 29. Okay, the directions for 29 and 33 are find the sum if it exists. Now, notice for this problem here, first of all, if you were to check and see, I believe you would see that you have a geometric sequence. And I believe what you're multiplying by is 4/5. 25 times 4/5 is 20. 20 times 4/5 is 16. So we do have a common ratio here of 4/5. Now notice in number 29 they tell us to find the sum, but do they tell us how many terms that we're adding together? No, they don't. So if they're not telling us how many terms that we're adding together, then we're going to have to use this formula right here, which is the formula for finding the sum of an infinite geometric series. All right, so we do not need these. Let's get rid of them. And this is the formula we're going to use right here. Now notice what I need to use this formula is I have to know what the first term is, and I know that, and I have to know what r is. and I know that also. Oh, by the way, I'm sorry, one more thing. You cannot use this formula unless r falls between -1 and 1. So think of a number line. Here's 0, here's 1, here's -1. 4/5 would be right here. So does 4/5 fall between -1 and 1? Yes, it does. So we can use this formula. So the sum of my infinite series is a subscript 1, that's 25, over 1 minus 4/5. So next I would have 25 over 1/5, okay, because 1 minus 4/5 is 1/5, and then 25 divided by 1/5 would give us the answer of 125, which is the correct answer. Now remember what we call this answer. We call it the sum, or we call it the limit. In other words, if you were to keep adding these numbers over and over and over, I don't care if you did a million terms, the sum really is not 125. You're getting closer and closer to 125, but you're never quite getting there. So we call that the sum, or the limit, of this geometric sequence. All right? Okay, let's take a look at number 33. Okay, students, on number 9, we're going to find the sum of this infinite geometric series. And the reason I know it's infinite is they don't tell us how many terms we're adding, okay? So, first of all, let's find our common ratio. If you take this term here and divide it by this term here, or if you take this term here and divide it by this term here, you will get 0.1. So what you're multiplying over and over here is 0.1. Now, that 0.1 does fall between 1 and -1, so we are good to use this formula here, which is the formula for the sum of an infinite geometric series. So here we go. The sum of this infinite series is a subscript 1, that's 0.6, over 1 minus 0.1. Okay, so now I have 0.6 over 0.9. Okay, and then of course if you simplify that, you will get 2/3. 2/3. You could type it into your calculator and get out a decimal and hit math, enter, or you could just look at it like this. You can move the decimal one place in the numerator as long as you move the decimal one place in the denominator. So you then have 6/9 and then reduce it and you get 2/3. Now again, this is called the sum or the limit. Okay, because if you keep adding more terms, it'll get closer and closer to 2/3, but it will never quite reach 2/3. All right, let's move on to number 37. They want us to find the sum. Now notice we're going from, now look at this, we're going from 1 to infinity. So it is an infinite, excuse me, it is an infinite sum. So we look at our formulas here, and these are the ones that we're going to use right here, or one of these is. Now let's see if we have a geometric series. We might not. Let's put a 1 in real quick. 1 minus 1 is 0. 1/2 to the 0 power is 1. Now put a 2 in. 2 minus 1 is 1. 1/2 to the 1 power is 1/2. Now let's put a 3 in. 3 minus, let me get a drink here please. Okay, thank you for your patience. Let's put a 3 in for k. 3 minus 1 is 2, and 1/2 to the second power is 1/4. Let's put a 4 in for k. 4 minus 1 is 3, and 1/2 to the third power is 1/8. So if you'll look, we are multiplying 1/2 over and over and over. So we do have a geometric series. Notice we do not know how many terms we're adding. We're starting with 1 and we're going to infinity. So we have an infinite geometric series. All right. So with that in mind, the formula that we're going to use will be the bottom formula here out of these three. And so here we go. We already found our first term was 1. We did that a second ago when we put 1 in for k. And then we found our common ratio was 1/2. So we're ready to use our formula. The sum of this infinite geometric series is 1 over 1 minus 1/2. So we would then have 1 over 1/2, which of course is 2. So the sum, or the limit, of this infinite geometric series is 2. Let's take a look at number 41. Number 41. Okay, here we go. First of all, if we were to put in, just trust me, if we were to put in a 1 and a 2 and a 3 and a 4, we would get out, sorry for yawning, I apologize, we would get out a geometric series, okay? So that's taken care of there. And I'm going to go ahead and put a 1 in very quickly and to get out the first term. And I'm doing that now with my calculator. 1.11, and I'm going to put a 1 in for k right here. 1.11 to the negative 1 times 500 is going to give me 450, 0.45, and then if I put a 2 in for k, I will get out this here for my next term, 405.81. But if you take these two numbers here and divide them, you're going to see that you're going to get out approximately 0.9. And if you were to continue listing out terms, you would see they're all being multiplied by 0.9, 0.9, 0.9. Now I'm rounding just a little bit because we are dealing with decimals, but the common ratio is 0.9. Okay, now let's think about what we're doing here. Okay, students, watch this carefully, please. We are finding the sum of a series that is going on for infinity, starting with term 1 and going to infinity. So we're going to have to use our formula in which we're finding the sum of an infinite geometric series. Number 2, you must make sure that your common ratio, by the way, this is your first term right here. I got that by putting a 1 in for k, 1.11 to the negative 1 power times 500. But anyways, if we're going to use this formula here, we have to know what the first term is, and we have to know what our common ratio is. And our common ratio, as I talked about a second ago, is 0.9. Now remember, in order to use this formula right here, your common ratio must fall between negative 1 and positive 1, and 0.9 falls right here, so we're totally fine. So with that in mind, let's go ahead and find the sum of this infinite geometric series. All right, so a subscript 1 is 450.45 all over 1 minus 0.9, or in other words, 450.45 all over 0.1. Now if you were to find this sum, divide 450.45 by 0.1, you would get 4,504.5. Now I'm looking at the answer here. We're off just a hair, probably because we rounded, but that's totally acceptable. So this would be your sum or your limit of the infinite geometric series. All right, let me get a drink here. We have 3 word problems to look at, and then we'll be finished. Okay, let's move on. Let's take a look at number, that's the wrong button, sorry about that. Let's see here. Let's take a look at number 51. As you read number 51, it should seem very, very familiar to a problem we did in your notes, and so this hopefully will be a help to you. Since you have some familiarity with this problem already. All right, here we go. Let's read number 51. You're offered a job for the month of February, so there's 28 days. You'll be paid 1 penny the first day. It doubles the second day, doubles the third day, and so on. So you're doubling your previous day's salary. How much would you earn together at the end of those 28 days? Well, let's see. Let's see if we can't figure this out. First of all, let's just write down what we have. We know we have 1 penny. The next day you would get 2 cents. The next day, 4 cents. The next day, 8 cents. And so I can see a pattern here. We're multiplying each term by 2 over and over and over. All right. Now, we're going to do this for 28 terms. So here's our first term, and we're going to keep getting all this money all the way till the 28th day. So I have a question for you. We're trying to add up 28 terms. So do we know how many terms that we're adding up? Well, yes, we do. We know we're adding up 28 terms. So since we know we're adding up 28 terms, then we know that we want to use the sum formula for a geometric series in which you know the number of terms. And that's this formula right here. So I'm going to write the sum of 28 terms equals, well, then I put my first term, which is 0.01, and then inside the parentheses 1 minus, then parentheses and put a 2. And then for n we would put 28 all over 1 minus r, 1 minus 2. Now, like I've told you, students, I'm going to get a red pen here, I would type this into your calculator first. I really would. That's the best way to do this. Trust me, okay? So with my calculator right now, I'm typing 1 minus, then parentheses, and then 2, then closing my parentheses, and then raising that to the 28th power. And if you do that correctly, here's what you should get. You should have a 0.01 on the outside of the parentheses, and on the inside you should have negative 268,435,455 all over negative 1. 1 minus 2 is negative 1. Okay, so then you take this number inside the parentheses and multiply it by 0.01, and if you do that correctly, all that it does is it moves the decimal 2 places. So now you have this right here, and then take this number and divide by a negative 1, and you will get this for your final answer. So after 28 days, you will have earned $2,684,354.55. Okay? So it's pretty impressive. You wouldn't think that would happen since they're offering to pay you a penny the very first day and then double it every day after. But that is what you would end up making after 28 days. So what we practiced there was finding the sum of a geometric series in which we did know the number of terms that we were adding. Let's take a look at number 55. Okay, number 55 reads as follows. I'm just going to paraphrase it. You've got a parent who puts $1,000 into a savings account, and the $1,000 is increasing at 3.2% compounded annually. Find the amount of the annuity at the end of 18 years. Now, I want to teach you something very quickly you need to see, okay? Please watch this very carefully. If you were to take $1,000 and find the interest on that, you would multiply it by 0.032. Remember this, please, from middle school math. 3.2% is the same thing as 0.032. If you were to multiply this, you would get out 32. Trust me, you would get out 32. And then you would add that back in, and your total would be $1,032 because you had started off with $1,000, you had gained $32 interest, so you would have $1,032. But there's a faster way to do this. If instead of taking 1,000 times 0.032, because your percentage is 3.2, instead of doing that, if you'll use 103.2%, in other words, just put a 1 right here. If you'll put a 1 right here, guess what happens? When you multiply 1,000 times 1.032, you get out 1,032. Now I hope that makes sense. In other words, you didn't have to multiply, get out 32, and then go back and add it into the 1,000. If you'll just put a 1 right here and multiply it, you get out your amount. Now we're going to apply that to this problem right now. So the first year that you have $1,000 in the bank, we're going to say that it gets multiplied not by 0.032, but 1.032. Now the next year rolls around, and this same amount right here is still in the bank, but now that whole amount gets multiplied by 1.032, and this continues on and on. Okay, this continues on and on. Now the only discrepancy in this problem that I came up with, my answer was off a little bit, is I'm not so sure. I think they wanted you to count 1,000 for the first year, and I didn't do that because you're supposed to figure at the end of the year. And if you leave this in a full 18 years, in my opinion, this is your first term here, and this is your second term. This is a really hard problem, but hang with me, watch, and just kind of, you might have to listen to it once and back up and listen to it again. But either way, we can do this, okay? So, anyways, if you'll look, we're multiplying each term over and over by 1.032. So your first term right here, when you multiply 1,000 times this, is 1,032. That's your first term. And your common ratio in which you're multiplying everything over and over by is 1.032. And we know how many terms we're doing this for. We're doing it for 18. So we're going to use our formula in which we find, let's see, well, I think I have it memorized. I hope I do. We're going to use the formula in which we find the sum of a geometric series with knowing how many terms we have. So the sum of 18 terms equals, and then you put your first term here, then I believe it's 1 minus, and then it's r, so 1.032 to the n power, and then close your parentheses. And then down here, let me go back and review and make sure I've got this right. I should memorize this a little better. It's 1 minus your ratio. So 1 minus 1.032. Now I've told you before, you type this whole part right here into your calculator. Alright, so I'm going to bring down the 1,032, put a parentheses, and very quickly now I'm going to type my calculator 1 minus, then close my parentheses, 1.032, close my parentheses, raise that to the 18th power. And I'm gonna round, but it's negative 0.76292799012 all over, hold on one second, 1 minus 1.032 would give you a negative 0.032. Now, your numerator, when you multiply these two together, is, I'm going to round it again, it's negative 787.34159441, and we divide that by negative 0.032. So let me type that in very quickly. And you're going to get this answer right here. Now we're off a little bit compared to the book, but once again I believe that's because of the differentiation and what that first term should be. And I would show some leniency on a test either way on that. But that's how much money you would have after 18 years by just starting off with $1,000. Okay? Alright, one more problem, number 59, and we're finished. Suppose the government is making a $13 billion expenditure for educational improvement. If 85% of this is spent again and again and again, so on, what is the total effect on the economy? Now notice we don't know how many times this happens over and over and over, so it is going to be the sum of an infinite geometric series, which I believe is a subscript 1 over, I'll have to go back and look, 1 minus r. So there we go. So it looks like our first term would be 13 billion. And then our next term would be 13 billion times 0.85, and then we would take that total and multiply it by 0.85, and then take that total and multiply, actually I forgot 3 zeros here, and then take that total and multiply it by 0.85. So this is our first term right here, and obviously what we're multiplying over and over is 85%, which is 0.85, and that's your common ratio. Okay, so here we go. The sum of this infinite geometric series would be 13 billion over 1 minus 0.85, and of course 1 minus 0.85 is 0.15. So with your calculator, if you type in 13 billion, and I'm just typing in to make sure that we get it right, and divide it by 0.15, you will get a pretty big number. Now mine comes out in scientific notation. It says 8 point, and it has a bunch of sixes, times 10 e to the 10th power. What that means is move the decimal 10 places. So 1, 2, 3. So the decimals here move at 10. So 1 would be 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like it would be about 86,666,666,666. But the point being is you can find an infinite sum, even though you don't know how many years you're going to keep adding this in over and over and multiplying by 0.85. But that would be the infinite, that would be a sum of an infinite series. Now, these are pretty tough problems, but they're good for you to think about. So that's it for the homework help video. Hope this has helped a little bit. If you have any questions, call me or email. Have a good day.